Hey, everybody. So today we are getting into chapter 11, which is all on the concept of similarity. Okay, or in other words, what does it mean for two shapes to be similar to one another? All right, today we're going to see how similar shapes are created through transformations. Okay, so before we get into it, go ahead and get this title here and get the definition of what a dilation is and what similar figures are, and we'll get into it. Okay, so 11.1, perform similarity transformations. You guys are going to, first of all, see that we've done these transformations before, but we didn't think of it in the context of creating similar shapes. So that's really the idea of today. Okay, and then after this section, we'll actually get into what does it mean when we have similar shapes. All right. So yeah, today, basically to create similar shapes, we're going to be doing some dilations. Okay, so just a little reminder on what a dilation is. It says a dilation is a transformation that stretches or shrinks a figure to create similar figures. Okay, so and that's kind of what's going on here. You can think of it as if this was our original shape and a dilation was applied to it. This looks like it would create, stretch this out to create a similar shape. Okay, one thing I want to point out, notice that even though these shapes are considered similar, they are not necessarily considered congruent. Okay, before this, we focused a lot on two shapes being congruent to one another. Okay, and basically that was just carbon copies of one another. They were exactly the same. Okay, similar shapes are not exactly the same. You can see these do not look exactly the same, though they do look very similar to one another, right? Okay, so again, we'll get into really what that means in the future, but today we're going to practice creating similar shapes. Okay, so on your graph paper, go ahead and get where your first graph is, get the directions at the top there and copy this first shape, and we will do this dilation. Okay, so on this one, it's asking us to use a scale factor of 2 to draw a dilation of ABCD. Okay, well, we can see our original shape here, ABCD, is already on the graph. They want us to apply this scale factor. And if you guys remember, what we do with scale factor is we just multiply it by the coordinates of this, this shape here. Okay, so that's really the first thing we need to do is figure out what are the coordinates of these points. All right, and again, a lot of this is just a review, but it applies to similarity, so that's why we're kind of going over it a little bit more in depth. Okay, so let's start with A here. So if you guys remember, when we find coordinates, start at the origin, first go on your x-axis and then your y-axis. So it looks like we're going to positive 2 on the x, positive 1 on the y. So 2, comma 1. Okay, B is at positive 4 on the x, positive 1 on the y. Okay, C is at positive 4 on the x, negative 1 on the y. And D is at positive 1 on the x, negative 1 on the y. Okay, so those are our, what I call the original coordinates, or sometimes the book will call them the pre-image. All right, but now we can apply our scale factor of 2, which if you remember, like I said before, is just multiplying by that number. So we're going to multiply all of this by 2, and we'll have our scale factor. Okay, so let's go ahead and do it. So when we go ahead and multiply by it, we're going to get our new a value, which if you guys remember is called a prime. Multiplying these by 2, 2 times 2 gives me a 4, 1 times 2 gives me a 2. Okay, and just doing that all the way down the line. So you can go ahead and finish out the rest of these on your own. Go ahead and multiply these by 2. All right, so there are my new points, my images, and now let's plot them, and we will see that we've created a similar polygon. So let's start with A prime. It's at positive 4, positive 2. Okay, don't forget to put the little prime symbol next to it now, so we know it's the image. B prime is at 8, positive 2, to the right, 8, up 2. Okay, C prime is at 8, negative 2, so to the right 8 down 2. And D prime is at 2, negative 2, to the right 2 down 2. All right, and yeah, let's connect the dots. Okay, and there it is. We've created a similar figure or a similar polygon. Technically, this is a quadrilateral. All right. So yeah, that's the idea kind of this lesson. You'll see we're going to use the fact that they're similar to kind of find missing points on one of these. But for now, we're just going to practice doing some dilations again. All right. So let's try one more together. This one is telling that we have a scale factor of 1/2. So maybe for your directions above your next graph, you can just get that scale factor of 1/2. Okay. And then go ahead and get these points, and then we'll do this one together. Okay, so this one, a little bit different. This one is giving us the coordinates of our original shape. So I guess maybe first thing, let's go ahead and get those onto our graph. All right, so A is at 4, negative 4, to the right 4, down 4. Okay, B is at 8, comma 2, to the right 8, up 2. And C is at 7, negative 3, to the right 7, down 3. Okay, so there is our original, our pre-image. All right, and this one wants us to apply a scale factor of 1/2. Okay, so we're going to be multiplying all of these by a 1/2. All right, so let's go ahead and do it and see what happens. Okay, so a lot of these are even, so we can probably do all of this in our head. Half of 4 is 2, half of negative 4 is negative 2. B prime, half of 8 is 4, half of 2 is 1. C prime, half of 7, not an even number, but if you think, if you grab a calculator, you just do it in your head, half of 7 is going to be 3.5, or we could say just 3.5. Okay, and same idea with this negative 3, not an even number, but half of 3 is 1.5. So half of negative 3 is negative 1.5, or negative 1.5. Okay, so yeah, if you have to, you can use a calculator when you multiply these scale factors. But yeah, let's see what happens here. So A prime is at 2, negative 2, to the right 2, down 2. Okay, B prime is at 4, comma 1, to the right 4, up 1. And C prime is at 3.5, comma negative 1.5. So to the right 3.5, and then down 1.5. So right there. Okay, and there we have it. Our similar polygon, triangle here was created. And so one thing to kind of remember when it comes to the scale factor, if we have a scale factor of a number greater than 1, we're going to get a figure that is an enlargement, a bigger polygon. Okay, if we have a scale factor that is less than 1 but still greater than 0, we're going to be getting an image that is I guess a shrink or a smaller polygon. Okay, so with this, I'm gonna have you guys go ahead and try one a lot like this. Go ahead and plot these original points, apply your scale factor of 4, and see what you got. Okay, so yeah, let me plot these real quick and you can see if yours matches mine. A is at negative 2, negative 1. Actually, I'm gonna make this blue like I normally do. Okay, so there's A. B is at 2 on the X, 0 on the Y. Be careful on that. C is at 0 on the X, 1 on the Y. Okay, so double check your original shape. Make sure it looks like mine. Make sure you didn't mix up those X and Y values when plotting those points. Okay, so there is my original. Okay, here's, the first thing I'm thinking. My scale factor is a number greater than 1. I am going to expect this thing to be an enlargement of my original shape here. So I'm going to be multiplying all of these by 4. So let me get these real quick. So a prime looks like I'm going to be getting a -8, -4. B prime looks like I'm getting an a comma 0. C prime looks like I'm getting a 0 comma 4. Okay, so let's plot it. -8, -4. There's A prime. B prime, +8, 0. And C prime, 0, 4. All right, and yeah, we do get, a big old enlargement here. And as you can see, we've created a similar shape. Okay, that's kind of the theme of this whole thing. We're creating similar shapes. Okay, so the last thing we're going to do here is what can we do with a similar shape? This is saying if the quadrilaterals are similar, what are the coordinates of S prime? Okay, we can actually use it to find missing coordinates. So go ahead and copy those directions above your next graph. Get these here and I'll show you what's going on. Okay, so here's what I'm thinking. S prime is right here. S is right here. S prime is probably going to land somewhere around here, right? That looks like it would give me a similar shape, but I'm wondering where exactly. Okay, well, how do I do this? How do I figure out the coordinates of S prime? Okay, well, the first thing I need to do is figure out the scale factor of these two shapes. Okay, here's the good news. To find the scale factor, all we have to do is compare one original point to its image. And then we can just kind of look and see, okay, this is the number that's being multiplied for us to get our image. So we can check any of these points. I'm going to use Q and Q prime. Okay, so the coordinates of Q is at a 1, 1. Okay, and it is turning into Q prime, and that is at 3, 3. Okay, so the question is what is the original being multiplied by to get the image? Well, these are really simple numbers. It looks like it's being multiplied by a 3, right? Okay, so we just kind of figured out our scale factor for this shape is a 3. Okay, now that we just figured out the scale factor, we can apply that to our S value to get our S prime value. Okay, so that's basically the last thing. So first, let's get the coordinates of S. Looks like it's at +2, +3. Okay, and now we can go ahead and apply that scale factor of multiplying by 3 and getting our S prime. Okay, and sorry, my S's look like 5 sometimes. Okay, so yeah, 3 times 2 gives me a 6, and 3 times 3 gives me a 9. I don't like that S. There we go. Okay, so yeah, there it is. There's the coordinates of S prime. It's at +6 on the X, +9 on the Y. So right there. Okay, and let's point out this is S prime. Okay, so yeah, that's just something to keep in mind. We can always use 2 points, just 2 points, one from the original, one from the image, to figure out the scale factor and then apply it to find missing points. All right, guys. So yeah, that's kind of a little intro, just to kind of get your brain wrapped around what similar shapes look like. In the future, we'll be using similar shapes and understanding, the properties of them. Okay, I'll see you guys.